All right, the first question asks you which model shows these equivalent fractions. 3/12 equals 2/8. What does equivalent mean? What does equivalent mean, Cash? The same, or what's another word for the same, Owen? Equal. Very good. Both of those, the same and equal, all would be words that would describe equivalence. So for fractions to be equivalent, the whole has to be the same size. Amy, what else has to be true?
That they have
How can I look at these and tell if they're equivalent or not? Justice, how can I tell if they're equivalent or not?
You can tell by if you look at the things and look at the lines, you can see if they add up to each other.
Yeah, if they have the same amount that are red or that are shaded. In this case, they're shaded red. So I'm looking to see if they have the same amount shaded. Looking at option 1, is that an equivalent to equivalent fractions? No. The top model has a little bit less shaded than the bottom model. All right, let's look at option 2. Are those equivalent? Yes, they show an equal amount shaded.
But they aren't the
Okay.
same numbers as they wanted.
Okay. Option 3, is that equivalent or equal, Dylan?
Option 3 is not equal because the first option is equal, but the second one just needs one more filled in.
Yeah, if I shaded in one more piece in that bottom, you're correct. They would be equivalent. How about option 4? Are they equivalent? Yes. So I know that the only two that could even possibly be the correct answers have to either be option 2 or option 4 because those are the only ones that have equivalent fractions shown. So how am I going to know which one's correct, Olivia?
By looking at the problem and read the directions.
Mm-hmm.
And it says 3/12 equal to 2/8, and that would be the fourth one.
Very good. Option 4 shows 3/12. That top model is 3/12. And the bottom model is 2/8. So option 4 is correct. No one should have missed that one. Okay. Let's take a look at number 2. Which model correctly represents the problem? So we're adding fractions in all 4 of our options. When we add fractions, what has to be true before we can add? Justice, what is it?
What it equals.
Okay, but before we can add them to see what it equals, what do we have to make sure of?
You have to make sure that the two numbers on the bottom are the same.
Exactly. The 2 numbers on the bottom, the denominators, have to be the same. And in all 4 options, I have 9 as the denominator, so I can add them all. Option 1, I have 8/9 plus 7/9. What's 8 plus 7? 15. 8/9 plus 7/9 equals 15/9, not 13/9. Option 2 says that 8/9 plus 7/9 equals 11/9. So that one can't be true either. Option 3, I have 8/9 plus 7/9 equals 15/9. So that's true so far. We need to see if 15/9 is equal to 1 and 6/9. How many ninths does it take to make one whole? If I break 15/9 apart and I take out the whole, how many ninths does it take to make one whole? 9. So if I take out 9/9, how many ninths would I have left? 9 plus what equals 15?
7. 6.
6. So if 15 ninths can be broken up into 9 ninths and 6 ninths, is it true that that would be equal to 1 and 6 ninths? That's true, isn't it? Okay, so let's look at our model now and see if it shows the correct amount shaded. I have one hole shaded and 1, 2, 3, 4, 5, 6 pieces shaded, 7, 8, 9 pieces in the hole. So that is true. Option 3 is the correct answer. What's wrong with option 4?
Because it's 6. It says 10 plus 7, and that would be 17.
Yeah, 10 ninths plus 7 ninths is equal to 17 ninths. Okay, questions about that one?
No.
There wasn't anything tricky about that one. Sometimes they trick you with the mixed number or even with the model, but there wasn't anything tricky about it today. Okay, so let's take a look at number 3. We have an area model, and we're missing a few parts. Cash, this is kind of like the one that you had on your study island assignment today, right? We had to figure out what we were multiplying. How am I going to know what A is in this problem? How am I going to know what A is, Brayley?
Because you add those 4 numbers.
Yeah, I'm going to look at the length of my rectangle. I have 3,000 plus 700 plus 40 plus 6. So I know that's the other part that I'm multiplying. A is going to be equal to 3,746. How am I going to know what B equals right here, Brayley?
Because it says it right before the times.
Yeah, it shows me in my problem 5 times. So B has to be equal to 5. How am I going to find C? Amy, what do I do to find C?
You do 5 times 7.
Yeah. The length is 6. The width is 5. And 5 times 6 is 30. So C is equal to 30. Questions about that?
No, ma'am.
Okay. Is there any reason that anyone should have missed that?
No.
Oh, we've worked hard on area models. We should be really confident with area models. Jacob, get yourself fixed there, buddy. All right, let's look at number 4. I want us to look at something because it kind of looks a little scary like that, doesn't it?
Yes.
Brayley, you've been doing really good with area models. So I want you to go draw me an area model that matches 6 times 18. Don't worry about anything else except for an area model that would show 6 times 18.
Right here?
Yeah, wherever you want to on that board.
Oh, now I get it. I already get it. Yeah.
All right, hang on just a second. I'm trying to get some space that I can write it on the tablet here so that it will show up in the video as well.
Hey, we're making a video right now?
Hang on, I'm almost there. Alright, so Brayley made the area model. How did you know what to... Just a second, let me fix that. Alright. So what did you start off drawing, Brayley?
Started started off drawing the box and then a 6, and then I divided the 10 into and 10, and then I took the 8 away from the 10.
Okay. So you made your short side 6, and then you split 18 into 10 and 8. So what would be the first thing? Well, actually, let's look right here. So what are we going to do to solve for this first part, Cash? What would we do to solve for this part right here? 10 times what?
6.
Yeah, we've got to multiply 6 times 10. So what do you think A is going to be equal to right here?
Wait, no.
60.
Is A equal to 60?
No.
Oh, what are we multiplying 6 by?
10.
10. A equals 10. Go ahead and write 10 up there, Brayley. So A is equal to 10. How are we going to find this part?
6 times 8.
6 times 8. So, Olivia, what do you think that B is going to be equal to?
8.
8. B equals 8. Go ahead and write it up there. Okay, so now we're actually going to solve 6 times 10. What is 6 times 10, Alexis?
6 times 10 is 60.
60. So what is C going to equal for 6 times 10?
60.
60. C equals 60. Okay. Then we have to solve for D. To find D, we're going to do 6 times 8. What is 6 times 8, Christopher? Six times, or 8 times 5 is,
That's what I do. I do
yeah.
8 times 45.
8 times 5 is 40. Then I would need 8 more, so that's going to be 48. 6 times 8 is 48. So D equals 48. Now what do I have to do to get E? What do I have to put together?
60 plus 40.
60 plus 48. And 60 and 40 I know makes what, Caden? My lesson's up here, not back there. Okay? What's 60 plus 40? Okay. Then I have 8 more to add, so that would make 108. E is equal to 108. Okay. Does that make it a little easier?
Yes.
Yeah. It looks a little scary when we see all this. But that's exactly what we've been doing. It's just broken apart into steps. Thank you, Brayley. You did a great job modeling that. Oh, sorry. No, that was my fault. All right. Questions about that?
No.
Could we solve another one if you had it?
Yes, yes.
Okay. All right. Number 5. We're looking for the model and equation that matches the problem. For every pull-up Mark completes, he does 4 push-ups. If he did 48 push-ups, how many pull-ups did he do? So for every pull-up he completes, every is going to mean 1. For every 1 pull-up, how many push-ups does he do?
4.
4. 1 pull-up is going to equal 4 push-ups. And it says if he did 48 push-ups, how many pull-ups did he do?
12.
So 48 push-ups is going to be equal to how many pull-ups? So I don't know that. I'm going to Make my pull-ups the variable. I know the total number of push-ups is going to be 48. How could we solve to figure out what's missing? How would I'm going to figure out how to get from 48 back down to 4. So what am I going to need to do, Justice? I'm not going to do times. What am I going to do?
You're gonna multiply.
No, not multiplying. I'm not timesing. What am I doing, Jacob?
Division.
Division. Okay, yeah, I've got to do backwards. So I've got 48 divided by 4 is going to equal what? 12. 48 divided by 4 equals 12. So I know that the number of pull-ups he did is 12. Now I've got to find the model that matches that. And Cash, I think it was you that said, but there's 2 that are the same.
Yeah.
Option 2 and option 3 both show 4 groups of 12. And then our answer is going to be 12. But he did 12 what? Pull-ups. Option 2 says he did 12 push-ups. In my problem it says he did 48 push-ups. So can that be the correct answer? No. So option 3 is correct. It shows that he did 4 groups of 12 push-ups, which is 48. And 48 divided by 4 equals 12. He did 12 pull-ups. Okay, good. So now you know what you would need to look for. Don't let those little things like that trick you, okay? All right, questions about anything on today's daily math?
No, ma'am.
All right.